So let's represent the LBA, the linear bounded automaton, in this way. So your control is much the same as a normal Turing machine. A normal Turing machine has an infinite tape, right? So it has effectively an infinite memory. That's a normal Turing machine. Whereas an LBA, a linear bounded automaton, its tape effectively is finite, right? Of length n, and that n is dictated to by the length of your initial input string, w, right? So in this case, it's just five symbols on the tape. Now, so if you're going to use this LBA to compute with, then common sense says the problem that you're trying to solve, it cannot involve memory that's too large for the capacity of the limited finite memory capacity of the LBA. I hope that's pretty obvious. Now you can increase that limit, the memory capacity of the LBA, by having a larger tape alphabet than you do the input alphabet. Remember this capital sigma? There's a bit of revision. Go back a few chapters now. This is the set of all possible symbols you can have in your input string, in other words, W. Right? And this is the set of all symbols that you can have on the tape. Okay, so you can have this can have extra symbols that are not in your string alphabet, your input alphabet. Okay, so by doing this, that'll give you a bit more memory capacity, but not a lot. I mean, it certainly doesn't make it infinite. So there'll still be a memory limit. Okay, and in fact, the memory capacity by having more symbols in your tape alphabet is in fact linearly proportional to the size of your limited tape. And in fact that's why it's called linear bounded automaton, right? Because by having a larger tape alphabet, you get a linear increase in the memory capacity compared to if you only had the string the input alphabet. So so the memory capacity of doing this is some constant of proportionality times n, little n. Where little n here is just the size of your initial input string. Okay, hence the name of this machine model. Okay, that's where it comes from. Yeah, that's just a detail. Now, okay, so we have this constrained, this limited Turing machine, this LBA. Question: how powerful is it? What can you do with it? Or an alternative question is, what can the LBA not do that the normal Turing machine, with its infinite memory, in other words, an infinitely long tape, can do? So, what's the distinction between a normal, unconstrained Turing machine and the LBA, which is constrained? Its tape is of finite length, effectively, and the Turing machine can move within that range, like between here and here, but that's it. The Turing machine can't move outside. It's like it's a finite length tape, effectively, right? Well, actually, the answer is quite surprising. It is quite powerful. Now there are differences, and we'll talk about them later on this board, later sessions. But now we've already talked about, for example, these languages we've already dealt with in earlier lectures. But the LBA is still sufficiently powerful to be a decider for this whole bunch of languages. A DFA and A CFG and E DFA and E CFG. Right? It's still, despite this constraint of a finite tape length, the LBA is still powerful enough to decide these 4 languages. Okay. So any context-free language that would be this can be decided by an LBA. Any context-free languages. Okay. In fact, another interesting comment by Sipser, that it actually you have to go to you have to make quite some effort to find a decidable language that is not decided by an LBA. Right? So virtually, well, I'd say many of the languages that are decided by an ordinary Turing machine, in other words with infinite memory, infinite tape length, a lot of those will still be decided by the LBA. Right? You have to go to some trouble to find an example of a language that is decided by a normal Turing machine, but that is not decided by an LBA. It's in other words, the LBA is quite powerful. Right? That might surprise you a bit. Right? So. Now, if you want to know how to do that, in other words, how do you go about finding a language that is decidable by a normal Turing machine and not decidable by an LBA? Well, you're going to have to wait a while, because there are techniques on how to do that, but they're in chapter 9, right? So more than a month away at the rate I'm going. Okay, but if you can be patient, there will be techniques presented in chapter 9 on how to